What's up, AP Bio Penguins? Today we're going to do a little AP Bio Math Minute looking at Hardy-Weinberg because y'all keep asking for it, and this is a student submitted question. So the inability to digest lactose is an autosomal recessive trait. In a population of 1,000 flies, 410 are unable to break it down. So what is the frequency of flies expected to be heterozygous in the population, assuming all 5 conditions of Hardy-Weinberg? So first thing, what's the equation? So looking at the equation, we know that our frequency of our homozygous dominant is our p squared, frequency of heterozygous is 2pq, and frequency of homozygous recessive is q squared, where our frequency of our dominant and our recessive alleles are going to be p and q respectively. So looking at the question, I know 410 out of 1,000 are going to be unable to break it down. So that's going to be my q squared. And I'm looking for 2pq in the equation. So let's move this up so we have a little bit more space. And y'all, as you all know, I always use this beautiful little chart to help me out whenever I solve it. So we know that 410 out of 1,000 are going to be unable to break it down. So that's our q squared. So 410 over 1,000 is going to be 0.41. If I know my q squared, I can then take the square root of it to find my q. So the square root of 0.41 is 0.64. Now p plus q is going to equal 1, so 1 minus q is going to equal p. So 1 minus 0.64 is going to give me 0.36. Now if I know my p, I can do my p squared, so square 0.36, and that's going to give me 0.13. And then, so if I want my 2pq, I'm going to do 2 times my p times my q, so 2 times 0.36 times 0.64, which is going to give me 0.46. So the frequency of the heterozygous in the population is going to be 0.46. Hope this was helpful, and remember that AP Bio Penguins was just assessed by y'all.